Here's another example from chapter 10, section 3, and what we're looking at right now is the integral from negative infinity to pi over 2 sine of 2x dx. So the first step is going to be writing this as a limit. So what we do is we take this part out, which is negative infinity, and instead of that we substitute t, and then we take the limit as t tends to negative infinity of the integral from t to pi over 2, so t tends to negative infinity of sine of 2x dx. Now at this stage you can do a u substitution, taking u to be 2x, and then taking the integral, and then at the end taking the limit. Or what you can do is you can use the formula, the integral of sine of mx, or this one over here, the integral of sine of mx dx, which is 1 over m cosine of mx plus c. Now don't forget that there's also a negative sign in front of it, because the derivative of cosine is negative sine. Okay, so we're going to use this formula. So here we get the limit as t tends to negative infinity of negative 1 over 2 cosine of 2x from t to pi over 2. Okay, so let's substitute these values in. So we get the limit as t tends to negative infinity of negative 1/2 cosine of 2 times pi over 2 minus let's move this over here. So minus negative 1/2 cosine of 2t. Okay, now the thing is that cosine is a function that's always alternating. So remember what the graph looks like. It looks like this. So it's always alternating between 1 and negative 1, so it never reaches a definite value. So this integral over here, this limit over here, t tending to negative infinity of cosine of 2t, this integral doesn't, this limit, doesn't exist. Okay, so what we do over here is we say that this limit over here, this limit here, the limit does not exist. And so therefore, we say that the integral is divergent. Now, not only does this hold for cosine, it would also hold for sine and for tangent, because these are all values that keep changing, and so therefore you won't have a limit if your t is going off to infinity.